Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 1 divided by x is equal to 27 to the power of x. Now, what I'm first going to do is I'm going to take the power of 1 over x on both sides. So now we have 1 over x to the power of 1 over x is equal to 27 to the power of x to the power of 1 over x. Now, if we have something in the form a to the power of m to the power of n, this is simply equal to a to the power of m times n. So as you can see here, we have 27 to the power of x to the power of 1 over x. This would equal 27 to the power of x times 1 over x. When for x times 1 over x, these x's simply cancel out, and we are simply left with 1. So this would be 1 over x to the power of 1 over x is equal to 27 to the power of 1. Now 27, this is the same thing as 3 to the power of 3. So now we have 1 over x to the power of 1 over x is equal to 3 to the power of 3. Now, if we have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So as you can see here, 1 over x is a in this case, and 3 is b, meaning 1 over x is equal to 3. Now, if I multiply both sides by x, these two cancel out, and I get 1 is equal to 3x. Now, if I divide by both sides by 3, these two cancel out, and I get x is equal to 1 over 3. So this is our answer. Now, to check, let's plug in x in this equation. So now we have 1 over 3 is equal to 27 to the power of 1 over 3. Now, 27 to the power of 1 over 3 is the same thing as the cube root of 27. And the cube root of 27 is 3. So now we have 3 is equal to, now 1 over 3 is the same thing as 3. So 3 equals 3. Because this is right, we know that our solution is right. Alright, so in this video, I'm going to be solving the system of equations m plus n is equal to 5 and m times n is also equal to 5. So obviously these two are two equations, and I'm going to label my first equation equation 1 and my second equation equation 2, just to make the solving easier. So my first equation is m plus n equals 5, and What I'm going to do is actually rewrite this so I get the value of just one of these variables. So I can choose any one. For the sake of this video, I'm going to choose m. So to get the value of m, I have to get rid of n by subtracting n on both sides. So then these two cancel out, and I get m is equal to 5 minus n. So now the reason I did this is because I can substitute this value of m back into my original equation. So if I substitute this back in, I get 5 minus n times n is equal to 5. Now, I can distribute the n. So 5 times n is going to be 5n, and negative n times n is going to be negative n squared. So I have this is equal to 5. And now I can add n squared on both sides and subtract 5n on both sides. And I get n squared minus 5n plus 5 is equal to 0. Now from here, to solve this, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 5, and c is positive 5. So I get n is equal to negative of negative 5 plus or minus the square root of negative 5 squared minus 4 times a, which is 1, times c, which is 5. And I have this all over 2a, so 2 times 1. And now this is equal to positive 5 plus or minus the square root of 25 minus 4 times 5, which is 20, all over 2, which is equal to 5 plus or minus the square root of 5 over 2. And this can't be simplified anymore, so n is equal to 5 plus or minus the square root of 5 over 2, which can be divided into two solutions. N is equal to 5 plus the square root of 5 over 2, and n is equal to 5 minus the square root of 5 over 2. Now, recall how m plus n is equal to 5. This was equation 1. So now what I can say is that m of 1 plus 5 plus the square root of 5 over 2 is equal to 5. Because remember, in this particular system equation, I can have two solutions. So m of 1, there's also an m of 2, because n has two solutions, meaning there's going to be two different solutions for the actual system equations. So we can say that this is n of 1 and this is n of 2. So for n of 1, respectively, I get m of 1. So now, to solve this equation, what I'm going to do is subtract 5 plus the square root of 5 over 2 on both sides. So then these two cancel out, and I get m of 1 is equal to 5 minus 5 plus the square root of 5 over 2. And I actually have to distribute the negative sign, so I get m of 1 is equal to 5 minus the square root of 5 over 2. And this is the same thing as 10 minus 5 minus the square root of 5 over 2, because 10 over 2 is equal to 5. So now from here, 10 minus 5 is just 5, so I get 5 minus the square root of 5 over 2. And I can say that this is my value for m of 1. And remember how n of 1 is equal to 5 plus the square root of 5 over 2. So my solution, my first solution for this system of equations is 5 minus the square root of 5 over 2, comma, 5 plus the square root of 5 over 2. So this is my first solution to the system equations. Now for solution number 2, I'm going to use n of 2. So n of 2 is equal to 5 minus the square root of 5 over 2. And to solve this, I'm going to plug this back into my equation, m plus n is equal to 5. So I can say m2 plus n of 2 is equal to 5, and n of 2 is equal to 5 minus the square root of 5 over 2. So I have m of 2 plus 5 minus the square root of 5 over 2 is equal to 5. Now to solve this, what I'm going to do is subtract 5 minus the square root of 5 over 2 on both sides. So then these two cancel out, and I get m of 2 is equal to 5 minus the square root of 5 over 2. And remember, this is in parentheses, so this is equal to 5 minus 5 plus the square root of 5 over 2. And again, 5 is the same thing as 10 over 2. So I get 10 over 2 minus 5 plus the square root of 5 over 2. And subtracting two fractions with the same denominator is equal to the numerator subtracting to each other over that denominator. So I get 10 minus 5 plus the square root of 5 over 2. And 10 minus 5 is 5. So I get m of 2 is equal to 5 plus the square root of 5 over 2. Meaning m of 2 comma n of 2, this is equal to 5 plus the square root of 5 over 2, comma 5 minus the square root of 5 over 2. So this is my second equation to this system of equations. And let me just write my first solution, m1 comma m2 is equal to 5 minus the square root of 5 over 2, comma 5 plus the square root of 5 over 2. And notice how these two are just the opposites of each other. m1 comma m2 is 5 minus the square root of 5 over 2, comma 5 plus the square root of 5 over 2, and m2 comma n2 is 5 plus the square root of 5 over 2, comma 5 minus the square root of 5 over 2. So these just switched order, and it still works out. So these two are my two solutions.